Hi and welcome to this en masse prediction for the Edexcel Higher Paper 2 Maths GCSE November 2020. Enjoy! Hi and welcome to this Paper 2 prediction from onmaths.com. If you haven't done the Paper 1, then you won't know that you can go and this link here and it will take you straight through to onmaths.com where you can try this paper out completely for free, and you can even sign up for free. It will save your scores and all that stuff. You can do that before you even watch this video, or what some people do is they like just to watch the video, understand how to do the questions, and then test themselves afterwards. So what is the prediction? Well, prediction basically is our estimation of what comes up every single time with this exam board, what hasn't come up in ages and is long overdue to come up, and it's basically a guess. And it's an educated guess, but it is a guess, and that's why I say in every video, don't just do this and rely on it 100%. There will be a lot of topics that come up in this paper, but there also will be new topics that don't come up. So make sure you do all your revision, whether that's with onmaths.com or mathseffect.co.uk or a different website or a different revision guide or whatever it is. Make sure you do the work first. Otherwise, let's get started. So this question says there's a tennis tournament being played where each player plays each other once. And there's multiple ways of doing this. One of the ways is listing out all the different combinations. But this question only asks for how many tennis matches are being played. So you don't need to list them out, and sometimes you will need to list them out. This one you don't. So let's start off with a liar. A liar has 4 people that they're going to play against. William, Paul, Samantha and Christine. William, well, we've already counted a liar's match with William, so William only has 3 left that he can play. Then Paul we've already counted his match with the other 2, so he's only going to play Samantha and Christine, other than his matches we've already counted. Samantha's only got Christine left to play after we counted all the other matches. And Christine's matches have already been counted so far. So, we've got the 4 matches a liar's going to play, 3 matches that William's going to play, not counting the one we've already counted from a liar, plus the 2 Paul's going to play, plus the other one that Samantha's going to play. So 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. So in total there are 10 different matches going to be played. Okay, factorise means put it into brackets. So looking at the first one, there's a t I can divide out of both of them. So I put t on the outside of the bracket, but there's no number because 7 and 5 don't have anything that goes into both of them. So I think, what do I times t by to get to 7t squared? Well, it's going to be 7t. And what do I times t by to get to 5t? Well, it's just going to be 5. You can check your answer by expanding the bracket. It makes 7t squared plus 5t, which it does. Next one, w is only in the first term, so I can't divide out the w, but there's a number I can divide out of both of those. Now, I could pick 2, but actually 4 is a better number because it says factorise fully, which means I need to take out or divide out the 4 rather than just the 2. So 4 on the outside. What do I times 4 by to get to 12w? Well, 3w. And what do I times 4 by to get to minus 8? It's going to be minus 2. And again, I can expand that to check it. Right, the last one, there's a number and a letter. So I'm thinking the number of 16 and 24 would be 8, and the letter would be A. Okay, so there's 2 things that we're dividing out this time. So I'm going to have 8A on the outside. So I figure out, what do I times 8 by to get to 24? Well, that's 3. And what do I times A by to get to A squared? Well, that's going to be A. What do I times 8 by to get to 16? 2. And what do I times 2 by to get to 16a, so it's just going to leave it because the a is on the outside of the bracket. So a to a times 2 is 16a, so I don't need an a there. So for this question, we just need to remember the area of a circle. Now the area of a circle is going to be pi r squared. Now that's the area for a full circle, my dodgy circle there, but we only have a quarter of it. Now if you have a look, that length there, the 22 centimeters, is going to be the radius of a full circle if I drew the circle properly. So we know what the radius is, and all we do is we times it by the fraction of the circle we have, which is going to be a quarter. So it's going to be pi times r, which is 22 squared, times a quarter. So I'm going to do that on my calculator. Pi times 22 squared, and then you can press equals and then just divide it by 4. That's the same as timesing it by a quarter. And the answer I get is 380.1327 blah blah blah. And so to 2 decimal places, that's going to be 380.13. Okay, so we're asked to write 88 as a product of its prime factors. So the first thing to do is write 88, and then we have 2 shoots coming from it. Now I need to find out which 2 numbers times together to make 88. Now a little tip, if you've got an even number, always pick 2. So 2 times 44. Now whenever we get to a prime number, we always circle it, because that's finished. So 44, we can get another 2 out of that, we'll divide another 2 out of that, so 2 and 22, 2 and 11. Now 11 is also a prime number, and when you're left with just prime numbers, then you write your answer out like this. Now if you're also asked to write it in index form, that means instead of 2 times 2 times 2, you're going to write 2 to the power of 3 times 11. Now don't work that out, because that will give you 88, so 2 cubed times 11 is 88. For this question, the main thing we need to remember is the triangle. Now the triangle is like the speed, distance, time triangle, but obviously this has nothing to do with speed, distance, time. The formula says that pressure equals force over area. So as long as you've got force on the top, which is measured in newtons, then you're fine, because area and pressure can be the other way around. So we're asked to find the pressure. So we cover up pressure on the triangle, we cover that up, and it says that it's force divided by area. And it says that the force is 2280 newtons, and the area is 38. So we get our calculator out, 2280 divided by 38, and I get the answer of 60. Now the units, because force is in newtons, and because area is either in meters squared or centimeters squared normally, then the units are newtons per centimeter squared. So it's 60 newtons per centimeter squared. Don't forget, it could be meters squared, newtons per meter squared, and that's absolutely fine for pressure. When you're asked to do a plan or a front or side elevation, it's important to remember that the diagram you're going to be drawing must be absolutely square on. So there's not going to be any 3D lines at all. It's just going to be 2D shapes like rectangles. Sometimes you have triangles. Occasionally you might get a circle or a semicircle. So let's have a think. What does plan mean? Plan means view from the top. So what of this shape are we going to see from the top? Well, we're definitely going to see this one. But we'll also see this one as well. Now we've got to work out what the sizes of them are going to be. Well, the top one's easy, it's just 7 centimeters by 6 centimeters. Now I'm not going to be able to draw this accurately because I don't have a ruler, but we can almost get it right. We can get it kind of right. And if I label it, that's going to be 7 centimeters, and that should be 6 centimeters. And in your exam, just make sure you actually measure them, because they are said to you in here, and it does say accurately construct. So you want to make sure that it's done 7 centimeters and 6 centimeters. Now, the difficulty is going to be the last bit. Well, we know it's going to be 6 across because it's the same as this one here. But what's the width going to be? what's this one going to be here? Well, if this one here is 7 and this one here is 9, what's left over? Well, there's 2 centimeters left over, so it's going to be 2 centimeters in width. Ooh. Let's use this one, right? So it's going to be 2 centimeters in width. So 2 centimeters there, and this one obviously is going to be 6 centimeters, the same as the right hand one. Now this line we have in the middle, this line here, is really important because that shows that there's a join, that there's something happening there. So you need to show that, especially if there's a change in elevation, just show it with a line on the diagram. Okay, so the first thing to do with this question is realise that x is sandwiched between -12 and -5. And all we need to do now is figure out what the sign's going to be. So x is going to be greater than -12, but it's also going to be equal to -12 because this dot here is filled in. X is smaller than -5, but it can't equal -5 because this dot here is hollow. Okay, so whenever we're asked to estimate with a scatter graph, we're always going to start off by drawing a line of best fit. So I'm going to draw my line of best fit, and yours might be different to mine, and that's absolutely fine. Now, it's asking us to estimate the height, and it's giving us the width. And that's really important because the width is up the side. So a common mistake would be to read 17 from the bottom, but the height is at the bottom. So we've got to check the scale first, and it seems like it's going up in 2s. So let's just check that. Yep, it's going up in 2s. So what I want to do is draw a line across at the width of 17, which will be roughly here. I'm going to stop when it hits the line of best fit, and I'm going to draw a line down, and I'm going to read off what that is. Well, this scale is also going up in 2s, I think. Yep, it is. So the estimate of the height would be 4 centimeters. Okay, so this is quite a tricky question because it mixes fractions and ratios together, but we've got to be comfortable with that. So I'd first of all just show the information so that I can get my head around it. So we've got Denver, who as a fraction has 3/19 of the food, and so that leaves how much? Well, we've got a calculator, so we could just do 1 take away 3/19 on the calculator, but we know that that's going to be 16/19. So we can kind of ignore Denver now because we used Denver's amount, or fraction of the food, to work out Engels and Fido's combined. So that's how much food they'll get, but they're sharing it in the ratio of 5:2. So in total, the amount of parts they have is 5 plus 2, which is 7. So there's 7 parts altogether. Okay, and each part, so one part, is going to be worth, well, as a fraction, it's 16/19 divided by 7. So 16/19 on the calculator divided by 7, which gives us 16/133. So that's the fraction of each part. Now it says, show what is Fido's share. So we're looking for Fido's share. Now Fido gets 2 lots of that. So looking for Fido, he gets 2 lots of that fraction. So I'm going to times that by 2 on the calculator, which is 32/133. Now it does say show your answer as a percentage rounded to the nearest percent. So to work between fractions and percentages, I just need to times by 100. So what I can do is just times that by 100. I'll do it on the calculator, times by 100, and press S to D if it comes up as a fraction, and it says 24.060 blah blah blah. So to the nearest percent, Fido gets 24%. Okay, I understand the temptation in this question to say that the answer is 0. Please do not write that. Anything to the power of 0 is not 0. anything to the power of 0 is 1. Now you can think about this. If you do x to the power of 5 divided by x to the power of 5, then the rule is that you take away the indices when you divide them, so it's x to the power of 0, and we know that any number divided by itself is always equal to 1. So the answer to this question is always going to be 1. Just try and remember that. Anything to the power of 0 is 1. Okay, so question A is about reverse percentages. So in 2014 and 2015, well, let's have a look. So the sales went down between the two. So if we start off with 100% and they went down 12%, what we're left with? Well, we're left with 88%. Now, as a multiplier, and this is the best way of doing this, 88% divided by 100, make it a decimal, is 0.88. Now that number, 0.88, is what we times the 2014 sales to get 2015. But in this question, we're given the 2015 sales, so we're given this one here. So we want to work backwards. So what we want to do is I'll get my calculator, 7,359 divided by 0.88, and that gives me £8,362.50. You've got to ask yourself, well, is that reasonable? Well, they went down by 12%, so it's natural that they would go from a number around just over 8,000 to a number that's just over 7,000. So I'm going to write the answer, £8,362.50. Okay, and the next question says that the sales went up in 2016, or they have a target to get their sales up in 2016. What's the percentage increase? Now, percentage increase or percentage decrease, it's the same formula, is change over original times 100. So the change, well, that's going to be 12272, take away the 2015 sales, so that's that one there, 7359. So they're looking for it to change by 4,913. The original was at 7,359, and we need to times by 100. So I'm going to divide that by 7359, times it by 100. And that gives me 66.7617, blah, blah, blah. So that's to the nearest percent, so that's going to be 67%. Now I'm going to be using the multiplier method for this question. If you've got a different method that works really well, then stick with it. But you do need to know the multiplier method for the GCSE. Now the word that probably tricks most people is this one here. Depreciates means goes down. Okay, it means it loses value. So it goes down by 1.7% each year. So to work out the multiplier, you first of all start off with 100%. Now this time you take away 1.7%, okay, because it's going down by 1.7%. And you can do that on your calculator or in your head. So 100 take away 1.7 is 98.3%. Then you want to work it out as a multiplier. So you're going to do 98.3%, and you just divide it by 100. And multiply is a posh way of saying decimal. So 0.983. Now, anytime I times something by 0.983, it will decrease it by 1.7%. So we've got a car we bought in 1980, and what is it worth in 1985? So that is 5 years. So it's going to depreciate by 1.7% every year. So we've got the 2,245, and if we times it by 0.983 once, that's 1 year. But we need to times it by that amount 5 times. And instead of writing that times 0.983 times 0.983 times 0.983 5 times, I can just do it to the power of 5. You get the same answer. So in the exam, you can just write times 0.983 5 times, and that's absolutely fine, you'll get the same answer. So 2245 on the calculator times 0.983 to the power of 5, and I get the answer of 2060.553687, blah blah blah. Okay, so because it's money, it's going to be 2 decimal places, so that's going to be 55. Now last thing is just to check your answer makes sense. Well, the car was worth 2,245. It has depreciated, but not by very much. 1.7% is not very much. So it's gone down, and it's lost about, say, roughly £200. So the answer makes sense. Okay, for Venn diagrams, it's really important to understand the notation. This symbol here means union. It just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18, or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an AND. I always put a little line there to say A for AND. And it means it needs to be in A and B. It can't just be in A, it can't just be in B, it needs to be in both. And there's 2 numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are 2 numbers that fit that bill. So that will go at the top of our fraction. And there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter. And so my answer to that will be 1/4, or a quarter. Okay, so we've got quite a lot going on with this question. We've got 3 planks of wood attached by glues and nails, or glue and nails, so we don't need to worry about the joins. But we're looking at the 3 planks of wood. Now, we've got 2 of the lengths. One is 6 meters and the other's 8 meters. But we need to find, obviously, the third length here to be able to continue with this question. So, given the fact it's a right angle triangle, and we know 2 of the length, and we're finding a third length, it's going to be Pythagoras. And Pythagoras says that a squared plus b squared equals c squared. Now c is the one that has to be the hypotenuse, and to find the hypotenuse we just go opposite the right angle. So we're finding c. A and b don't matter which way around we do it, so I'm going to do 6 squared plus 8 squared equals c squared. And I can put my lines down as I normally do. So I always put the lines down that equals. I've just missed that one. So 6 squared is 36, 8 squared is 64, which equals c squared. 36 plus 64 is 100, equals c squared. What I'm going to do is just square root both sides, so c will equal 10. Now when you square root you get a negative as well, but since it's a length it can't be negative, so it's just going to be 10. So c is 10, so we know that that's going to be 10 meters. And it says it takes 90 millilitres of paint per metre of wood to cover it. So what we're going to have to do is work out how much wood we have. So I'm going to say to the examiner wood length or something. Always try and describe to the examiner what you're doing. So we're going to do 6 plus 8 plus 10. So 6 plus 8 is 14 plus 10 is 24. Okay. And then to work out the amount of paint required, so paint required, I need to do 24 because we've got 24 meters of paint times 90 because it's 90 milliliters per meter. So we can do this with the grid or column method. Doesn't really matter which one. I'll do the column, why not? So 0 for the first one, and then we're going to do 90 times 4, so we need to add a 0. 9 times 4 is 36. 9 times 2 is 18, plus the 3 is 21. And what we could have done is 9 times 24 and just added a 0 onto the end of it. There's loads of different ways of doing these things. So it would be 2,160 millilitres. If you ask this in litres it would be 2.160 litres, because there's 1,000 millilitres in a litre. Okay, so we have a set of simultaneous equations, and I'm just going to start off by just writing them out to give myself a bit more room, because it's a little bit too small otherwise. So I'm just copying out the question. Now, there's a list of things we need to do for these, and there are different methods. I'm just going to go through the main one. The first thing is I need to get either the x's or the y's the same coefficient, so the number before them needs to be the same, ignoring signs. Now looking at this, and I'm going to label these A and B. Looking at this, if I double A, then the x's would become the same because they both have a coefficient of 4. So what I'm going to do now is I'm just going to write 2A. So I'm going to double everything in A. So double the 2x to make 4x to make the x's the same. Double the 5 before the y, so that's 10y now. And double the 24 to make 48. Now, next, I need to probably, and it's normally the case, if I write down B again, it just makes things easier. So I'm just going to literally copy down B underneath. Okay, so next I'm going to remind myself that I'm working downwards now. So I just put little circles around these to remind me I'm going downwards. And I need to look at the sign before the letter that I've made the same coefficient. So I'm looking at the x's and I'm looking at the signs before them. If the signs are the same, we are going to subtract. If the signs are different, we're going to add. And it's that simple. Okay. Now the signs are the same because they're both positive, so we are going to be subtracting. So a minus there, a minus there, and a minus there. Okay, let's start. 4x take away 4x is nothing, which is good because it needs to be nothing. 10y minus 3y. Now 2 minuses make a plus, so that's 10y plus 3y, which would be 13y. And we've got 48 plus, because the 2 minuses make a plus 4, which is going to be 52. I'm going to put my lines in. Okay, next I need to do 52 divided by 13. And we're going to do both of these divided by 13. So we've got y equals, I think it's 4. So 4 times 13 is 52. So yeah, y equals 4. Then I'm going to pick one of the equations from the question and I'm going to substitute the 4 in. I'm just going to pick the top one. So 2x plus 5 times 4, because we know that y is 4, equals 24. And again, put my lines in. So it's 2x plus 20 equals 24. Take away 20 from both sides. 2x equals 4. Divide both sides by 2. Extend my lines a little bit. And x equals 2. Now if you've got time in the exam, you can check that that's right by using the second equation. So 4 times 2 is 8. 3 times 4 is 12, and 8 take away 12 is minus 4, so we know it's correct. So x is 2 and y is 4. Okay, so in this question we're asked to enlarge shape A by scale factor -2 with the centre of enlargement 2,5. So normally we'd first of all put the centre of enlargement on, but it's already done for us. So what I need to do now is draw my ray lines, but because it's negative we know they're going to go through the centre of enlargement. So I'm going to draw my ray line. I don't need to do the bottom right one because it will essentially be the same thing. And let's do this one. Let's try and get it as perfect as we can. So it should be something like that. Okay, now next thing to do is count how many squares we went away So I'm going to start with the bottom left point. So we've got 1, 2, 3, 4 to get to the centre of enlargement. So if it's -2, we're going to go another 4 twice. So 1, 2, 3, 4, 1, 2, 3, 4. So we end up here. Okay. For the next one, let's do the bottom right one. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're just right on the edge there. Okay, let's do the last one. So this time I'm going to count the diagonals, and if you had a ruler you could just measure it out. So 1, 2, 3, 4 diagonals. So 1, 2, 3, 4, 1, 2, 3, 4. Okay, and now we need to connect them all up. So let's connect them all up. And probably it will say label it B, yeah. So label it B. And always check the width of A was 2 and the width of B is 4, so that's good. The height of it is 4, and so the height of B should be 8, which it is. And it looks unusual because for an enlargement you're used to it being the same way around, but for negative enlargement it basically just flips it. Right, when working with bounds, the easiest way of answering the question or thinking it through is just to do a quick number line, put the number that's been rounded in the middle, and try and figure out what the next one down is. Well, it's to the nearest 5, so the next one down is going to be 80. Now we could do the next one up, but it's asking for the lower bound, so we're only interested in the lowest possible values. Now, next thing is to work out what the cutoff point was. Why was it rounded to 85 and not 80? At what point did it need to be higher then? Well, the point at which it needs to be higher is halfway between the two, which is 82.5. So that's our lower bound for the 85. Then just repeat the process for the 160. So we've got 160 in the middle. And the next one down would have been 155. And then when we draw the line, well, it's going to be 157.5. Now, what many students would do is just look at the number. Well, the area is going to be 85 times 160, and that's what the area is going to be. But we know that the 85 could have been 82.5, and the 160 could have been 157.5. And that would give the lowest possible area. So if I get my calculator out, 82.5 times 157.5, and that gives me 12993.75. And it doesn't ask me to round it, so I'm just going to write down the exact number. Now be careful, with areas we're timesing them, so we want them both to be small, but if you were to divide them, sometimes you actually want the upper bound of one of the values, but for area you want them both to be as small as possible to give us the lower bound for the area. Okay, so we're asked to find the nth term of the sequence, so the first thing I need to do is work out what the sequence is going up in. So 9 to 22 will be 13. 22 to 41 would be 19. It's not the same. Okay, so that would be 25, and then this would be 31. Okay, so whenever you have a sequence that's not going up by the same amount, then the next step is to work out what the differences are going up in. The difference of the differences. Well, that's 6, and this one's 6, and this one's also 6. So if the difference of the differences is always the same, then you've got yourself a quadratic sequence. And the way of dealing with that is get the difference of the differences and always halve it. Okay, so we end up with 3. Now that 3 will go before an n squared. So we know our nth term will involve 3n squared. but we don't know what the rest of it is yet. So what we do is a little table, and we write in our sequence, which is 9, 22, 41, 66, and 97. And then we write down the sequence for 3n squared, which is going to be 1 squared times 3, okay, because n is 1 for the first term. So that's going to be 3. 2 squared is 4 times 3 is 12. N is 3 for the third term, so 3 squared is 9 times 3 is 27. N is 4 for the fourth term, so 4 squared 16 times 3 is going to be 48. And then 5 squared times 3 is going to be 75. Now what we want to do is take 3n squared out of our sequence. So if I call this sequence, we're going to do our sequence and we're going to take away 3n squared from it. So basically what I'm doing is I'm going to do 9 take away 3, which is 6, 22 take away 12, which is 10, 41 take away 27, which is 14, and I'm just going to keep subtracting them. Now you might notice that we've got a linear sequence now. This linear sequence that's formed is going up in 4s. So each one is going up in 4s. And we find the nth term of this linear sequence. So we're going to have 4n, and then we're going to work out what the 0th one is. I've not left myself very much room, and that's going to be 2. So our 0th term is going to be 2, so we know it's going to be 4n plus 2. So we put this bit here with this bit here, and that gives us our nth term of this quadratic sequence. So it's 3n squared plus 4n plus 2, and that's our answer. Now you can check this out by putting in 1 and putting in 2 and putting in 3 and seeing whether you do get 9, 22 and 41, which you will do. The first thing to do with this question is, instead of drawing y is greater than 2, just draw y equals 2, and you do that by just finding out where y is 2. Well, y is 2 here, y is 2 here, y is 2 here. So it's going to be a horizontal line crossing the y-axis at 2. So that's the line y equals 2. Now, the inequality says y is greater than 2. So what I want to do is shade out the region that we're not looking at. So we're going to shade out this bottom region here because we don't want that. And some teachers say shade in the region you want, but it's a lot easier to see the region you want if you shade out everything else. Otherwise you're looking for overlapping regions. Okay, so that is done, so we can cross that off. Okay, next one, we want to do the line x equals minus 1. Okay, so where does x equal minus 1? Where does there, in fact all the way up this line here. So we want to do another one. And that's the line x equals minus 1. Okay, so where do we not want? Well, x is going to be greater than minus 1, so we don't want this bit at the side here. Now, on both of the ones we've done so far, y and x can't be on that line. So instead of a straight line, we should really do a dashed line to show that it actually can't be on that line. So I'm just going to make this a dashed line. Okay, now the last one, I'm going to do the line y equals x plus 2. Now, there's multiple ways of doing this. You could do a little table and find out where the coordinates are. So you could do 1, 2 and 3, and I'm just making those up. It could be 0, 1, 2 and 3. And 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5. So that's our 3 coordinates to be able to draw the line. Or you could just say, well, the gradient of x is 1, because technically that's 1x, and the y-intercept is 2. So it's going to cross the y-axis at 2, and it's going to go up 1 for every one it goes across. And notice that matches my coordinates as well. So let's draw that in. So down there we go. So it should be that line there, shouldn't it? Okay, now the complicated part of this is figuring out which side of this line to shade in. So what I do is I always pick a point. So let's pick this point here. It doesn't matter which point you pick. So at that point there, x is 4 and y is 3. So what we want is y to be greater than or equal to x plus 2. Now x plus 2 is going to be 4 plus 2, which is 6. So is 3, which is our y coordinate, greater than or equal to 6? Well, no, 3 is not greater than or equal to 6. So that shows us that we want to shade in this bit because we don't want this bit. So that coordinate was part of the region we didn't want. Now you can do the same on the other side with a coordinate, say this one here. So x plus 2 is 2 plus 2, which is 4, and y is 7. So 7 is greater than or equal to 4. Okay, last thing to do is just label it with an R. So that's the region I'm looking for there. So I label it with an R. So with this, it's an algebraic fraction, but just think of it as a normal fraction first. So just think you're doing a half plus a third. How would you do it? Well, you've got to get the bottoms the same. You've got to find a common denominator. Now the way we do these when they are algebraic expressions is just multiply both of the algebraic expressions together. So with a half plus a third, the common denominator would be 6, right? So you get that by just timesing the 2 and the 3 together. Now that doesn't always get you the best common denominator to use, but it will always work. It's just sometimes the numbers get a little bit big. So we're going to do that. Now whenever you see an expression in a fraction, always just imagine or physically draw in brackets around them, and that helps us. Now the common denominator between both of those is going to be just those 2 brackets. So what I want to do is times both of the left hand side by the right hand bracket and times the right hand side, or yeah, you know what I mean, times the right hand side by the left hand bracket. Okay, so when I do that, I've got 3 times x plus 2 at the top, and then I've got x plus 5, x plus 2, plus 9 times x plus 5 over x. And I'll write x plus 5 first, just so it looks the same. Okay, now we can just add the tops now. So I can just add the tops together, and the bottom is the same, so I'll just write it once. Now I'm going to expand the brackets at the top, so 3x plus 6 plus 9x plus 45. Okay, now I need to collect the like terms at the top, and I'm just going to put this into my answer box. Now it might need it expanded, so I'm going to expand the bottom as well. So the bottom will be x squared plus 7x plus 10. If you don't know how to do that, see our video on expanding quadratics, or expanding quadratic equations, or expanding quadratic brackets. And let's collect the like terms at the top. So 3x plus 9x is 12x, and then 6 plus 45 is 51. And that's my final answer. Now in the exam, it doesn't always need you to expand. I could have left the bottom with brackets around it, unless it explicitly tells you to. So I think on the website for this question, it asks you to expand all the brackets. So if the question asks you to, you do have to. Looking at the structure of the answer, it looks very much like we're going to have to complete the square. Now, to complete the square, we need x squared minus something. Okay. Now we've got 2x squared, and so minus something x. We've got 2x squared minus 28x. So we're close to getting that, but we haven't quite got that. So what we need to do is factorize the 2 out first. So 2 brackets x squared minus 14x. And then I'm just going to add the minus 4 at the end. You could also factorize out the 4 as well, but I'm just going to leave that alone because I'll deal with that later. Now that we've got what we need to be able to complete the square, which is the x squared minus something x, we are going to complete the square. Now to complete the square, and I'm going to do this over here to show you a little bit easier. What you need to do is you need to put the x minus half of the bit here, so it's going to be 7 squared. Now that will get, if you expand that, that will be, or using FOIL, that would be x squared minus 7x plus 49. Now we need the x squared, we need the minus 7x to get the minus 14x, but we want to get rid of the plus 49 that it generates. So we need to take away 49 from it. And that's it, that's completing the square. Okay, so I'm going to replace that with what I've just found out that it is, x minus 7 squared minus 49. Now, I have that minus 49 on the inside of the brackets, and I want to collect that with the minus 4 on the outside of the brackets. So I'm going to just expand the big brackets. So I'm going to times the x minus 7 squared by 2. And I'm going to times the minus 49 by 2. And so I can collect the numbers together. So looking at the question, it says it wants m. M is the thing before the brackets, so m is going to be 2. Now it says that p is a positive. Well, we know that p is minus 7, so I'm going to put minus 7 there. And q, it says, is a positive. Well, we know it's a negative, so it's going to be negative 102. There are a few different methods to answer this question, but I prefer the method where we just replace f of x with y because it becomes a lot easier. So I'm just going to write out the same equation. Now, when you want to find the inverse, which this is, of the function, all you do is swap the y and the x around. So we're going to have x equals 4y minus 10 over 7. And then all we need to do is get it so we've got y equals. So the first thing I'm going to do is times both sides by 7 to get rid of the fraction. So we've got 7x equals 4y minus 10. Then I'm going to add 10 both sides. So we've got 7x plus 10 equals 4y. And then I'm going to divide both sides by 4. So I've got 7x plus 10, all of that over 4, equals y. Now, it's not y really, it's f, inverse of function, x equals 7x plus 10 over 4. And the 7x and the plus 10 can be either way around. So 7x plus 10 over 4. This question might just ask you to rationalize the denominator. It might ask this question the form that's in, or it might ask you to show that that fraction is the same as another one where you'll get marks for the working out. So to do this one, what rationalizing means is basically what this one's here, because if you look, there's no root at the bottom there. What rationalizing means is to get rid of the square root off the bottom of the fraction. Now I'm going to write this out again to make it a bit bigger. Now the only way we can do that with this question is if we times top and bottom by kind of the opposite of what it shows at the bottom. So instead of 11 plus root 5, I'm going to times it by 11 minus root 5. But if I do that to the bottom, to keep the fraction the same, I must do it to the top. So that creates a kind of quadratic surd. Okay, you do it the same way as you do quadratics, whichever method you want, first outside, inside, last, or double smiles and rainbows, or smiley face, or whatever you choose to do it. So I'm going to do the top first. So I'm going to do 5 times 11, which is 55. I'm going to do 5 times minus root 5, which is minus 5 root 5. I'm going to do 11 times root 5, which is 11 root 5. I'm just going to extend my line a little bit. And root 5 times minus root 5, well, positive times a negative is a negative. And any surd, when you times it by itself, it just becomes that number. So root 5 times root 5 is just 5. Okay, let's do the same with the bottom. So 11 times 11 is 121. We've got root 5 times 11, which is plus, it's 11 root 5. Then we've got minus root 5 times 11, which is minus 11 root 5. And then we've got positive root 5 times negative root 5, which is minus 5. Okay, now you might see what happens at the bottom. The whole purpose for doing this is you end up with the surds cancelling each other out. So let's simplify the top. 55 take away 5 is 50. And minus 5 root 5 plus 11 root 5 is going to be, well, if you think about it, you've got 11 of something and you're taking away 5 of it. Well, what you're left with? Well, you're left with 6 of it. So it's plus 6 root 5. Okay, now let's go through the bottom. Well, the two middle ones have cancelled each other out, so it's 121 take away 5, which is going to be 116. Okay, can I do anything else with this? Well, I don't think there's something that's in 56 and 116 apart from 2, so we can cancel all of that. We can halve all of those, so that becomes 25, that becomes 3, and that becomes 58. Now, the 3 doesn't go into 25, so we can't cancel it any further. So it's going to be 25 for A. B is the coefficient of the root, so it's going to be 3, and the bottom number is 58. To be able to answer questions like this, you've got to be able to sort of think in 3D. So try and imagine that this box is sitting in front of you. You're asked to find the angle GEC. So if we go from G to E to C, then we're being asked to find this angle here. Well, we know to find an angle, we're probably going to be using trigonometry. And at the moment, we only have one length. We have that 11 centimetres at the end, which will be the opposite. So if I mark that, that's the opposite when we use trigonometry. Now, the hypotenuse is not something we can easily find. So the hypotenuse here, well, we can't really easily find that. So that's probably not what one that we're going to be looking for. But the adjacent at the bottom, if you have a look at the bottom, the adjacent here could be quite easy to find, because if you have a look at the right angle triangle here, we have 2 of the lengths. We've got the 5 and the 6, and we're looking for the third. And because it's a cuboid, we know that that's a right angle there. So the first thing I would do to start this question off is just copy down the triangle that we've got at the bottom. So it's 6 centimetres and 5 centimetres, and all of them in centimetres, so I don't need to put the units just yet. Okay, so to do that we use Pythagoras, so we're going to square them, add them, and then square root it, and we call this EG. There's line EG, not for example. So, I mean, we can use our calculator for this. Root 25 plus 36, and that's root 61, and we can leave it as root 61 because we don't want to have to round it at this point. Okay, so the next thing to draw is the right angle triangle that the purple one that we've got on the diagram. So let's start drawing that. Oops. Okay, so we've got A at the bottom, which we now know is root 61. Let's scroll down a bit. And the height is 11, and we're looking for this angle here. And we can call this angle X, why not? Okay, so to do this question, we need to label the sides first. So that's the opposite and that's the adjacent. We need to just quickly write SOHCAHTOA so that we can check which one it's going to be. And it's TOA that has the opposite and adjacent. And so we're going to write down tan, and we called it X, equals opposite over adjacent. Tan X equals, well, the opposite's 11 and the adjacent is root 61. And we're going to inverse tan both sides. Just standard trigonometry. So inverse tan and fraction 11 over root 61, and just close the bracket. There we go. And it says that X is 54.62438 blah blah blah. It says it wants its 2 decimal places, so the answer I'm going to write is 54.62. Okay, so we've got a cubic graph here because it goes down, then up, and then down again. And we're asked to find the equation of the graph. Now, the problem with this is the normal method is to put down 3 brackets, and any solution it gives us in the graph, we write down the opposite, the inverse sign, right? So for this one here, it would be x minus 6, because 6 take away 6 is 0, therefore that's a solution. And for this one here, it would be plus 7, because 7 take away 7 is a solution, right? Because it equals 0. But the problem we have here is we've kind of run out of solutions. And therefore, the natural thing is to think, well, maybe it's a quadratic. But we can see it's not a quadratic, it is a cubic, so it needs to have 3 brackets. And not all cubics make 3 brackets, but this question will. So we've got to think, well, hang on, we actually have 2 solutions here. We've got the down solution and we've got the up solution. So that actually represents 2 solutions, not 1. And if you have a look at here, we've just got 1 solution because it just goes through once. So when it turns on the axis, it gives us 2 solutions. So there are 2 lots of x plus 7. So a bit of a unique situation, that, but it's useful to remember.
Well, I hope you found that video useful. If you did, please click like. If you want to see more from us, including the other 2 papers, please click subscribe. We've got loads and loads of stuff on the website on maths.com, which you can go to here, which is completely free. But if you feel you're quite far behind in the maths, or you're not happy with the grades you're getting on maths.com or other mock papers you have, you can try out our premium service, which is mathseffect.co.uk. With mathseffect.co.uk, it's a small monthly fee, and you can do an annual subscription, but if you only want to do it up until November, which makes sense, you can just pay per month. And what it does is it has the whole of the maths GCSE as a journey, and you go through each topic, mastering it 1 topic at a time. A lot of the students I talk to say, I really don't know where to start. Like, I keep doing Pythagoras and trigonometry over and over again, and I don't really know what else I don't know. This is a service which just covers everything. It makes sure you master and you are an expert in every topic in maths. So it's worth checking out. Loads of people have joined already, and if you haven't joined, go to the website mathseffect.co.uk or click the link in the description. That will take you straight there and you can check it out. Otherwise, thank you very much. If you want to leave a comment down below of anything you want us to cover, because we're desperate to help anyone who's being caught up in this terrible situation, which is not ideal for anyone, but equally, like, we all understand why it's happened. But if I was having to resit or having to sit for the first time in November, I would feel exactly the same as you are probably feeling. So if you want to leave any comments down below, and we might release some videos just discussing options that you have open, or whatever it might be. Otherwise, thank you very much, and I'll see you in the next video.